This video is a Matlab tutorial for beginners. I would assume that you know basic coding concepts and have experience in some other language, but new to Matlab, so this is the video for you. So first, I want to say that there are at least these two kind of programming language. So the first one, you use that to develop an application, and this application is going to be used by others, like an phone application or web application. But there is also another programming language that mainly focuses on computation. Matlab is one of it, and if you are a Python user, you also may hear about this NumPy, SciPy, and Matlab. It is sometimes included in one very big distribution package called Anaconda, so it is also used for computation. And if you are a statistics major, you may hear about R is also used for computation. Sometimes people say that Matlab is not a programming language, it's just a big calculator. So it is true, because Matlab is just used for doing computations, but some computations can be very complex that you need to use coding to do that. Okay, first thing into Matlab is the IDE. Let's take a look. So this is the IDE. Usually you have 4 windows there: editor, command window, workspace, and current folder. If you cannot find any of them, just go to tab Home, Layout, and check what is missing. And if you have different layout than I do, you can try this layout, or just drag the window somewhere you want, like here, or I prefer it back here. So what do these windows do? So the workspace is where all the variables are going to be shown. And so the command window is where you want to try to do quick calculations, try out small things. And editor is where you mainly work with. You're going to write scripts, functions. Basically, you are programming in this window. Current folder is how you manage your Matlab project. It's like Matlab project is organized by folders, so current folder means current project, and current folder shows all the stuff, all kinds of files in the working directory, and working directory is set here. So let's try out a little bit. So in command window, you can type out quick calculations. Like I can assign 1 to a variable called a equal 1, and then you have a, and a is shown up here in the workspace. I can also create a matrix, another matrix maybe called b equal to 1, 2, 3, 4, and you have b here. And in the workspace, a common behavior is you can double click on the variable and you can see the data in a table. The editor, when you click on the editor window, there will be an editor tab. If you click this tab, you can run this current script. Like, let's click run, and you can see that the variables inside the script will also show up in workspace. So to recap, workspace is for variable, and we can check the summaries of the variable in workspace. Like here, this is the name, and we can check the size of the variables. And value also mean standard deviation, minimum value, maximum value. If you want to add more, right click here, and you can see other information that you can check, like the median. Then you have another column called the median. It is also good to view the result in debugging. An editor is the main working place. We're going to use that to edit a script, function, also live script. We're going to talk about that later. And command window is used for debugging and try out small things. The current folder is used for project organization. Then let's go to the basic syntax. So you see that a lot of Matlab lines are ended with semicolons. And actually you can have a line that does not have semicolon. So what's the difference? If a line is not ended with semicolon, the result will be printed out directly. If it is ended with semicolon, the result will be hidden. Let's do one operation like give 1 to A and without a semicolon. Then you see the result is printed out directly, A equal to 1. If we do the same operation with a semicolon, then you see the result is hidden. So in the script, because we just want the final result, most of the stuff in the middle, we just want to hide the result of this. So you see most of the Matlab lines are ended with a semicolon. For comment, we use a % symbol for comment. This is one line that you try to plot or one figure. When we run this script, you don't see any figure plotted out because this line is commented. So if I remove the % sign in the beginning and run that, you see a figure there. Matlab is not sensitive to indentions and it's not sensitive to space. So I can actually add space in the middle of a line but does not affect the result. It's also not sensitive to indentation, so I can have an indent here without changing the result. So you don't need to define a variable before you use that. This is similar to Python and VB. Parentheses are used for both functions and indexes. So this is a little bit special among all languages, so please remember. And there is a very special variable named ans, which means answer. So if you have an operation that has a return value, but it is not assigned to any variables, it is automatically assigned to a system variable called ans. So let's try that. Like I can assign 1 plus 1 to b, like b equal to 1 plus 1. So you see a b here has the value 2. But if we do something like 1 plus 1 but does not assign the value to anything, you can see the answer ans equal to 2. So this variable is created automatically when you are doing one operation but does not assign the output to any variable. So it is a common behavior that you do this in the command window, because in command window you just want to check out some result, do quick operations, quick calculations. But it is not very common that you use that in script, so don't use that in script. It is used mostly for debugging and checking. Data manipulation. Yes, we are doing calculation in Matlab, so we want to know how data look like in Matlab. So basic idea is Matlab, every variable is a matrix. That means a scalar is a matrix and vector is a matrix. So everything is a matrix. A scalar is a 1 by 1 matrix. A variable may be a 1 by n matrix or n by 1 matrix. It depends. So it is different. there is difference between a row vector and a column vector. And there can be more than 2 indexes, so the minimum number of indexes is 2, and there can be more, like you have a tensor, like 3 indexes, 4 indexes, as more as you need. And index start from 1. So for most of the language, index start from 0, but Matlab start from 1. And the third thing is 99% of Matlab data are immutable, and that 1% you won't use very common unless you are defining some classes, which is not very common used, or if you're just doing our course project, you're not going to use that. Data immutable means there is no pointer-like thing. So every copy is a deep copy. If you assign x to y, that means you're copying the value of x and give that value to y. And all the functions are passed by value. So you're not going to have anything like pass by reference or pass by pointer to the functions. If you use any variable as a parameter of the function, actually you're just copying the value of that parameter into the function. So because we're trying to do the signal processing project, we are going to use a lot of complex number. So in Matlab, it is very easy to use complex number. So you can use just one I or one j to represent j. So for our engineering society, j is often used because I is often used in for loops. Like, let's try it out. Actually, you can use I, but it's not recommended because I is often used as an iterator index in the for loop. So what we often use is just one j or one I. And you can use 1 plus 2j to represent a complex number. And there are 4 functions that are very useful for complex number. imag is taking the imaginary part of that complex number, real is taking the real part, angle is taking the angle of the complex number, and the magnitude is taken by the abs function. Sorry, this a should be lowercase abs. We can create a matrix by this method. The first is we can create a series. We use cone to separate start, step, and stop. So this example is start from 0 and end at 10, and the step size is 0.1. So if step is just 1, you can omit that, because so this is 1, start from 1, step 1, and end at 10. You can actually write that as 1, 10, and the step is 1 by default. You can also create all ones matrix by this function once, and this 1, 2 is the size of the matrix. This means I'm creating one all ones matrix that has 1 row and 2 columns. Similarly, you can use these zeros to create all 0 matrix. This is 10 row, 2 column. Or I can just type out the data I want inside a pair of brackets. I use comma and semicolons to separate the data, and when I separate data by comma, that means the data are in different column. And if I separate data by semicolon, that means this data, these 2 parts of data, are separated in different lines or different rows. Let's try it out. Like I have a equal to 1, 2, semicolon 3, 4. And you can have this a as 2 by 2, and you see 1 and 2 are in first row, 3 and 4 are in second row. Also, you can generate random numbers, and this is also the size. This is Gaussian random number, 2 rows, 3 columns. So in this project, you probably are not going to use that, but if you're doing through this project, this is very useful. And if we want to combine two pieces of data, we can use brackets and separate the data by comma or semicolons. If we separate by comma, that means the two pieces of data are side by side. And if they are separated by semicolons, that means I'm stacking these two pieces of data vertically. You can also select a subset of a matrix by putting an array inside the index. Like, as we said, parentheses are used for indexing as well as for functions. So here is for indexing. X parentheses 1, 10 means I'm taking the first to the 10th element inside X and give these 10 values to another variable called Y. Let's try this out. Let's create an series like X equal to 1 to 100. You see all these numbers, and you can also check it out by double click on X. You see this 1 and to 100, and I want to take the first 10 elements out and give that to Y. Then I have Y equal to X from 1 to 10. Let's check it out. So Y has 1 to 10 values. So there's a special word called end. That means the last element. In Python, if you have ever used that, it is represented by -1. But in Matlab, it is a keyword called end. So let's do one example. If I want to take the last 3 elements from X, I can and give that to Y. I can have Y equal to X. End can be included in one operation of end, like end -2 to n. That means the last 3 elements inside X. And you see Y equal to 98, 99, and 100. Also, if X has more than 2 indexes, like it is a matrix, not a vector, you can separate the ranges by comma. So this means X, the first row to the second row, the second line to the second column to the third column. So there is another shortcut. You can use just con to represent 1 to end. And there is another special operator called equal to empty set. So if you have X and represent one submatrix of X and let it equal to an empty set, that means you are removing this subset from the original matrix. So let's try to do that. Let's try to remove the first 10 elements from X. So that is X 1 to 10. equal to empty set. Let's check it out. So see, it starts from 11, that means 1 to 10 are removed from the original X. Also, we can measure the size of a matrix because we sometimes remove the column, and we can also combine different matrix. So we sometimes want to measure the size of the matrix. So let's see what is going on here. Size is a function. It takes a matrix as the input, and size will give you two output. The first output is the number of rows, and the second output is the number of columns. And if we want to receive this two output, we are going to have two variables on the left hand side of the equal sign, and put these two variables inside a pair of brackets. So m will be the number of rows, n will be the number of columns of X. And if we just want the number of columns, or I should say we want the second number of the size function output, we can use another parameter like size X, comma 2. That is the number of columns of X. And if we know that X is a vector, we can use length instead of size just to get the length of the vector. So a little trick is, if we want to generate a matrix that has the same size of the original matrix, you can use ones, zeros, or random, and just put size of the matrix what we want as the input of that matrix generation function. Control flows. So because I know that you guys are all programmed in some other languages, so I'm not going to describe what is a for loop, what is a while loop, or what is if else. I guess you guys already know that. But I want to mention that in Matlab, there is no goto, and there is also no do while. But you can use while and break to mimic a do while if you really need that. But for most of the time, we just need for and if else. While is not often used, sometimes it's used, but not as many as for. For is the most used control flow. And switch case, well, I should say switch case will make your code look much longer in Matlab. I just suggest you use if, else instead of switch case. Well, for try catch, unless you are trying to manipulate some potential error, you are not going to use a try catch. But it is good to know that this thing exists. Sometimes it can be very useful if you are attempting to do something scary, something risky. So the syntax of for loop is a for in the beginning and end at the end. Indentation is not necessary, but highly recommended because it will make your code look better. And after the for, usually we have one iteration index equal to a series, like from 1 to n, or from 2 to 10, or any range. Actually, you can also have one variable equal to a vector. So that means for each element inside the vector. But that is not as much used as an iteration index equal to a range series. Continue and break are also supported, so it is the same as continue and break in other languages. Continue will continue to run the loop, but don't run anything after the continue inside the loop. Break is actually exit to the loop. If statement, so also you can use if else, else, end, and after if statement, you just write a condition there. So you can write a lot of conditions. So the most famous one is if 1 and if 0. That means if true and if false. So if can take any value, a scalar value, as input. So if it is not 0, that means true. If it is 0, then that is false. If can also take an matrix as a condition. If a matrix is not empty, then it's true. If it is empty, then it's false. You can also try some logic operations as a condition, like any can be. You can also use some logic operations as the condition, like you can use the function any, or you can use equal to and does not equal to. So and means and, logical and in Matlab. And by the way, just a single and means bitwise AND operation, and these two symbols means OR. So for data visualization, that is usually one part of your Matlab project, we have a figure that creates a new figure window. A plot is used to plot continuous signal, and stem is used to plot a discrete signal. Hold down is like when you want to plot more than one signal inside just one graph, you use hold down after the figure. And if you want to plot multiple plots but inside one figure window, you can use subplot to stack your plots inside the figure window. Let's try some example. So you have already seen this plot here, and let's run that. You see this is continuous signal. And if it is discrete, I'd better change the step size into 1, and let's use STEM. So you see this signal is discrete, and there will be a bar at each data point. So the first figure is automatically added there, and if I want to add another figure, I should have a figure here. So this will give me 2 figure window. If I want to have these 2 signals in the same figure window, like one is discrete and one is continuous, I would have one hold on after the figure. So I would put figure before all the plot and have hold on immediately after the figure window is created. And let's plot that. So you see there are 2 signals. One is continuous and the other is discrete by these 2 lines of code. And if I want to plot the figures in different figure but in the same window, I can use subplot. So there are three parameters of subplot, and if you want to plot a matrix of plot, then you need to know the number of columns, the number of rows, and where you want to put the subplot is. So for example, I want to plot two figures stacked vertically, then there is two rows, one column, and the first figure on the top and second figure on the bottom. So the top figure is this one, so let's put the first parameter is number of row, is 2 rows, and the second parameter is number of columns, 1 column. Because this is the upper figure, so it's the first figure, I put 1 here, so it's 2, 1, 1. So before the second plot, we also put a subplot function here. It is still 2 rows, 1 column, and this is the second figure, so I put 2 here. So let's see what's going on. Then you see 2 figures stacked there vertically. So this part, I want to introduce some coding habits that helps you organize your code better. So first, I want to say there are 2 kinds of files, even though they have the same file type. They are all .m files, but actually they are different. One kind of file is script, the other is a function. So script is just a few of lines of operations. You can calculate everything, but a script does not have input or output. It's just a few lines of operation, and all the calculation will have variables, and these variables will all go to the workspace. Different thing for functions. Function is also several calculations, but it can have input and output. It can have no input or no output, but usually it can have input and output. And the variables defined inside the function will be released when the function returns. That means they are not going to appear in the workspace. This is similar for function definition in all other languages. So for a script, you must have the 3 lines in the beginning of your script. The first is clear, that clears all the variables inside your workspace. Close all the figures. All the figure window will be closed, and CLC will clean up all the printed out result in the command window. So we have close, clear, close all, and CLC. Let's see what's going on. So I have a figure window open. I don't have anything in command window, but let's try to type some. A equal to 1. Okay, I have something here. I also have workspace. And let's try to debug this. So I'm going to put a breakpoint here, so only the first 3 lines will be wrong when I click run. So let's run, and it stopped here. So you see the window disappear. There is no plot window anymore, and nothing in the workspace, and the command window is empty. Why you need to do that? Because you are not going to run the script one time. You're going to run multiple scripts when you're working, and you are going to run multiple times of your script while you are developing that. So before each run, you want everything to be clear. You don't want to be affected by last run, so you want to clean up everything that has relation to the previous run. So you must have this realized in the beginning of your scripts. And for function, so in Matlab, function is a file, it's a function file. So function file must have the same name as a function. So let's try to create a function file. So we use new function, then we have a new function file. So you see when it's created, you have a function file, a function name here, and this is the name of the function file. They have to be the same by the rule of Matlab. And function can take inputs and output. Oh, by the way, you have to have this function keyword in the beginning and end at the end. Function can have multiple input and multiple output. So multiple input are separated by comma inside parentheses. Multiple output are separated by comma inside brackets. And you do all the operations here, but you don't need to have a return inside the function because the values that are going to be returned are represented here by output variable names. So actually it is very flexible where you write the function, but it is suggested that for each function you write that as a standalone function file. No function in the end of the script, and no function as subfunction in other function files, because this will give you an easier way to debug these functions. And also you can call this function somewhere else, like in the command window, if there are standalone function files. For example, if you have function inside a script, this function can be called nowhere other than the script itself. It's like you cannot use that function in your command window. For example, if I write a function called myDouble, I can write function keyword in the beginning. Function y equal to my double x and end the file with end. The operation here is y equal to x times 2 semicolon, because I don't want this to be printed out, and I don't need to return because y is already here. Let's save the file by the same name as the function name, and then in the command window I can use my double 3 and it can have 6, and in the test you can also have my like y equal to my double 10 and run that. And you have y equal to 20 here because I didn't semicolon that out. But if you have a function inside a script, like I define a function here like y equal to my half x and y equal to 0.5 times x, you can use z equal to my half 10, wrong that. You can have a z equal to 5 using my half inside the script, but outside the script, like in the command window, when you try to call that function, it will give you an error. So it is easier that you define all functions as a standalone function file. So a typical Matlab project will look like this. A Matlab project is just a folder. Nothing fancier, just a folder. So everything related to one project should be put in one folder, and when you try to work in that folder, set working directory to that folder. It will contain several scripts, but I should say that each problem you are trying to solve should only have one script. Like in the project, you have multiple problems, like you may have one script for 1.3 and also another script for 1.4. But for 1.3, you are going to have one and only one script. The script is function like the main function in most of other languages. So as you see, in each project only have one main function. That's similar in Matlab. Never call a script inside another script. This is a bad habit. I saw people do that. You should not do that. And you can have many functions, and each function should be just have one single purpose. So this is the same as most languages, and each function file should just have one function. As I said, no function inside script and no subfunction inside other function files. And you can also have other data files like image file, waveform file, and also readable documents like readme file, your Matlab project. And LiveScript is a very good way to develop this readable document, and I'm going to talk about LiveScript later. Some useful tips like useful shortcut, keyboard shortcuts. F5 is used to run, and Ctrl R and Ctrl T are used for common and uncommon. Like here, I can have common, Ctrl R, Ctrl T, and then if I select multiple lines, I can have Ctrl R to comment all this out and Ctrl T to uncomment all this. And Ctrl I is for auto indentation. So for this function, actually, okay, this is fine. But if I have very bad indentation, like here, here, and here, so this is a very bad indentation. What can I do? I can select these lines, Ctrl I, and they all go to the right indentation. And you can Ctrl A to select all, and Ctrl I to auto format all your code, and your code will look very good. So breakpoint and run, so I've already tested that, so I'm going to see that again. So run and debug are the same button. So just set up a breakpoint by clicking a bubble here, and run. If it has breakpoint, it will automatically go into debug mode, and you have step in, step out if you have functions, continue, and same thing for most of IDEs. And there are 4 ways you can get Matlab documents. The best way is always Google it. So just the Google Matlab and the function name. And let's try thing. Oh, I don't have internet now, so just Google it. Or if you are unfortunately offline like me now, you can use help, like go to home and help. This is sort of an offline version of that. Let's try to type one function name like FFT, and you have the description of FFT. Well, you see I'm offline now. I can use this help document here, and MATLAB documents are usually very good. You have these examples, figures, and parameter definition, related reading, everything you need. Very good. Also, you can use command help something. This is easy to check it out if one function is included in your installation packages. LiveScript. LiveScript is a very good tool that you develop your project report. You can contain titles and taxes, codes, figures, and also equations inside MATLAB LiveScript. It is very similar to Jupyter Notebook, but all inside MATLAB. You don't need to go anywhere else. So let's try to create one LiveScript. So new LiveScript. I suggest that you use vertical, looks better, and you can type like text. So create a title called project, and add some descriptions like what is this, and also you can have functions like insert equation, like power as. This is very similar to Word. And if you know latex, you can insert equation, a latex equation. You can have x squared and insert that. And of course, you can put MATLAB code here. So we can have clear, close all, and CLC. And then let's try to create a figure. It's like t equal to 1 to 0.1 to 10. And plot t sin t. And when I click run and wait for a little bit, so LiveScript a little bit slower than ordinary scripts, but you can see what's happening. The graph is included, and if you save that as M file, you see your descriptions are going to become comments, and code are still there as code. You can run it and get the same result. You can also save that as PDF, like report, and you are going to have a PDF file that has the same look, exact same look as what you have in this LiveScript. Here you go. This is the PDF file generated. So actually you can write your whole lab report just by LiveScript. Reminders for your project. So this is a simple project. So if you don't understand what I'm talking, you can just ignore that. So I saw people submit MATLAB project using GUI or MATLAB application. You don't need that. It is too complicated for this simple project. And don't use command line input. So for like C project, sometimes you are using cin, cout, or scanf. You don't need anything like this. So for application, you need user interface, but for calculation, you can put all the data into data file or in the script. You don't need user interface. A good calculation script should give you all the result when you click on run button once, nothing else. And you want to avoid using built-in function name as variable name. So if you want to check if one variable name is already used, you can just type help and to see if there is any document about that. So like if I want to use exp, I will check that by help exp well, there is a function like that, so I cannot use ESP as a variable name. And important thing be said again, don't forget these 3 lines: clear, console, and CLC. And also comment your code as much as you can. This good habit for all languages.